My video stopped. So again, so today's date is the 18th of March 2026. The time now is 18 a.m. So you're gonna stand and now this is gonna work for you. Asymmetric symmetric model again. Basically, the drone is gonna fly up and down, left and right, and side to side. But you have an orange, and take an orange, for example, and you're gonna have to take 2 points A and B. You're gonna take it and you're gonna slice the orange in half. When you slice the orange in half, you have a path, the A star algorithm that the system always tracks. By tracking the orange path, you have basically the flight pattern, the flight trajectory of the shortest path between 2 points on a surface, on a round surface. And this three-axis reference symmetry can map out the round surface because this we has three axes of symmetry. So it has up, down, left, right, side to side. But it can use to compute this over. So you have the goal is basically a system of um so you're gonna have a drone be flying here, but flying right and side to side. So obviously, if you have this drone attached to a spring, and that spring goes up and down, so you have a 500 grams of which is a food item, and that 500 gram of food is a bag of rice. You're gonna be able to fly in the around the orange, which is basically a total orange, and be able to fly into the orange. But not just the surface. So the map was from point A to point B, and that's also point A to point B. So you're gonna have the so you're gonna have a system of fly up and down. The drift theorem, which is dt minus pt dt equals to pressure point t minus c2, which is camera pressure point. Now the camera is basically facing the three axes of and there's no this triangular prism, which is the formula again is triangular prism formula or triangular pyramid. Volume formula is defined as the base times the faint face basically from the So you're gonna have the formula equals to half times the perimeter times the slant. So half times base times height times L the slant times P the perimeter, which times a half the side of the triangle perimeter. So you're gonna have half times base times height for the base, and the height will be elevated times L slant, which basically the triangle perimeter is usually three-axis symmetry mirrors inside the system that's opaque, that's transparent. So two transparent mirrors. That's this. And this two-dimensional transparent mirrors are the furthest axis of interpretation. Observe and interpret our system over three-axis symmetry. But this two-axis symmetry is basically worth looking into a bit more because it's basically tripolar. Tripolar. No, because you can connect, disconnect, and reconnect. I don't even know why it's reconnect, but it's really a tripartite system. You the ground, you the user, V the nation, where the place live, and UVW, which is the axis, people that have a graph, W, which are you the drone, you the food, the bypass food, V the food, and W the person that's going to take it down. So tripartite model of the three symmetric graph. We have a B square, which calculates which comes reference over the double magnitude, which is you see the magnitude twice of the B, which is basically the drift time, the T. Now capital T, which is time, or the double magnitude of B squared minus 4AC. Are not just supposed to the user and use the user way. We do the second model here. Now, the model the food is basically 5 kg, the 5 mg, 5 grams, 500 grams. 500 grams of food is a bag of rice. This bag of rice is above the height of 50 meters, which is the law. So 500 grams of food over 50 meters is literally which is 500, which is a 10. So the thing that's measure that there's 10 way there's 10 distribute across the symmetric axis. 10 of space distributed across let x y is equal in the system over the polar space, over the polar axis, over the rotation, elevation, and rotation XYZ, roll pitch here. The food will then fall out the drum, if not. But while doing so, as long as it's no more than 10, the drone is literally carrying this kg of food, and this can go up and down, up and down, up and down, and increases sine and cosine wave, and that's because basically the drone observing its path to course or not via inverse kinematics or kinematic principles. Of the user. But because I have my other laptop here, so I can program the interface the network on Windows system, and Windows will be sharing out, and by sharing on network, you can GPS, and that's the goal. That's good. So you have the last model here, which basically the system knowing like so we're gonna be spinning anticlockwise twice. So two anticlockwise space will give you this kind of system here, and you have to flip this plane. One flip for sending and a flip for verifying the message of the circle. So this is a circle here. Now this circle is a radar system. So you can find the space. Polo, the game Marco Polo, but Marco Polo on RadioDish, on the space you upload. So if I move my laptop here and there. Because the two laptops connected to the network, and one represents food, one represents Marco. And same for the drone system, Marco and Polo. So it doesn't matter where I put my other laptop, as long as they're able to find each other. Based on Marco and Polo. So one laptop is called Marco, the other is called Polo. So that's go. So the drone delivery system. So again, the drone carries 500 grams of food. The food is in flight. The food goes up via the spring physics. Which is basically a trident, which is inside a trident, which is a triangle-based pyramid, and that pyramid occurs three axis symmetry, which reflects information in a bidirectional way, in a tridirectional way, graph via the drift theorem. The drift theorem was the time, obviously, it's just 10 kg over, because, it doesn't matter what food it is, but, the system can remain coherent above via a system of non-rigidity. So it's flying up and down. But this drift theorem ensures that, that you get inverse kinematics principles and you get kinematics principles. So, involved in this. So you're gonna get, for example, you're gonna get the first the second derivative, which is control model, and based on the integration of the system two, two. So you're gonna have the second integration. So you're gonna have the third derivative, the second derivative, and then the third derivative, and then you're gonna have control, command, control, and collapse. Based on the drum and how the going to based on the orange or so you can deliver the food as a payload safely to the user as a flight. But this is basically obedience resolution system. So you get to reach the depth point zero, and then you can go to another system. So basically, the depth point zero is 2 pi, because the 2 pi is the oscillation frequency of the drum via electromagnetic memory. The goal, basically, it's not the EA system per se, it's not the EA system. The goal for the drum to have electromagnetic principles. So the magneticness of the drum increases ahead of time because you knows what's running. So this is the magnetic electric. You don't need to separate the electric signal represents the runtime because you can run the electric. It's magnetic, so it's really magnetized to the person. So it's Marco and Polo on the RadioDish laptops, or two drones, or two entities who are drifting away from each other. That's to go to. Just watching this video. Today's date is the 18th of March 2026. The time now is 11:31 p.m.